What if the Earth isn't what we think it is? Not in a conspiratorial sense, but in a deeper, more mind-bending way. What if the debate between a flat Earth and a round one is based on a false premise? The idea that it has to be only one or the other. Let's start with something seemingly unrelated, the atom. In the early 20th century, physicists discovered that atoms, the tiny building blocks of matter, don't behave like little marbles as once thought. Instead, they exist in strange quantum states, capable of being in multiple positions, energies, or even forms, until they're observed. This is called superposition. A single particle can spin clockwise and counterclockwise at the same time. It can be in two locations at once. It can act like a wave and a particle until someone checks. This is the quantum world, a place where reality doesn't solidify until it's measured. Now let's take that unsettling concept and scale it up. What if, just for argument's sake, the Earth operated like an atom? Could it be flat and round, depending on the perspective? Could it exist in multiple shapes at once until observed, just like a quantum particle? Of course, this idea sounds ridiculous. The Earth is enormous. It has gravity, mass, oceans, mountains, atmosphere. It's not a quantum particle. But bear with me. Let's stretch our imagination for a few minutes. Let's imagine a conscious being so massive, so astronomically large, that it perceives the Earth the way we perceive an atom. From its perspective, Earth isn't a spinning ball of rock. It's a flickering energy cloud, just a probability field. A hazy dot with properties that only make sense once you look closer. Would that being see Earth as flat? Round? Both? Or would it see something else entirely, something our human minds aren't equipped to process? This sounds like science fiction, but it taps into a very real debate in physics. Does scale change the nature of reality? In quantum mechanics, the answer is yes. The rules that govern electrons, quarks, and photons are not the same rules that govern basketballs, oceans, and planets. We live in the classical world, a world of certainties. But deep down, the universe is ruled by probabilities. Now let's return to Earth. The shape of the Earth has been settled scientifically for centuries. It is an oblate spheroid, slightly flattened at the poles, bulging at the equator due to its rotation. We have overwhelming evidence: satellite photos, global circumnavigation, gravity measurements, the Coriolis effect, the way ships disappear hull first over the horizon, and countless other clues woven into our daily experience. Yet the flat Earth theory persists. Why? Because sometimes perception fights reality. Standing on a wide plain, the Earth feels flat. Looking at the ocean, it seems still. The sun looks like it rises and sets. Our eyes tell a simple story, but science tells another. Still, the question remains: why do we trust quantum mechanics to explain particles but draw a line when it comes to scale? Is it really absurd to imagine that we, too, live inside a system that we don't fully understand? And if atoms can exist in multiple states, could our Earth have properties we haven't yet discovered? Here's another wild idea. In quantum physics, observation collapses the wave function. It turns a fuzzy cloud of probabilities into a single outcome. Before you observe a particle, it might be here or there. Afterward, it's definitely somewhere. Now imagine that, in some far-fetched metaphorical sense, humanity's observation of the Earth, our study, our measurements, our technologies, have collapsed its reality into the shape we now see. The round Earth isn't just true because it's measured. It's true because it's been observed. But what about before that? What about ancient civilizations? Cultures that describe the Earth as flat, not out of ignorance, but because to them it was flat. In a world without measurements, satellites, and calculations, could reality itself, or at least experienced reality, have been different? There's a philosophical name for this idea: observer-dependent reality. It doesn't claim the Earth was ever objectively flat. It suggests that for a mind without tools, flatness was real enough. In the same way that a quantum particle is neither here nor there until measured, Perhaps the truth about the Earth's nature was also in superposition, waiting to be collapsed into one form or another by our growing understanding. Now, of course, this is not to say Earth was ever literally flat. The goal here isn't to promote pseudoscience or conspiracy. It's to explore something deeper. How much of what we call truth is shaped by perception? How much is shaped by scale? And most importantly, could we still be missing something? Because here's the twist. Just as early physicists thought atoms were indivisible little balls until they discovered the nucleus, then quarks, then quantum fields, maybe our picture of the Earth is still incomplete. Not in shape, but in meaning. Maybe Earth is more than a planet. Maybe it's a system that responds to perception. Maybe our minds, our collective consciousness, play a greater role in the construction of what we consider to be reality than we ever thought possible. And that brings us to our real question. Not, is the Earth flat or round? But can the Earth be something more than just a shape? Can it be a clue, a metaphor, a lens through which we begin to understand the next layer of reality? To understand how deeply this question reaches, we need to shift our focus from Earth's surface to the structure of space itself. Because at its core, this isn't a debate about geography or physics. It's a debate about perception. And perception, as science increasingly shows, is malleable. Consider this. We don't see the world as it is. We see the world as our senses allow. The light spectrum is vast, but we perceive only a tiny fraction. Infrared and ultraviolet are invisible to our eyes, yet very real. The same goes for sound. We hear a narrow range of frequencies. Dogs hear more. Bats hear differently. If our senses shape our perception, and our perception shapes our reality, then what is the world really? Now let's extend that to shape. We say the Earth is round, but in truth it's not a perfect sphere. It's lumpy, dynamic, constantly shifting, a living system of tectonics, magma, water and air. What we call round is an approximation, a simplification, a human concept that describes the average of a chaotic reality. What if someone existed with the ability to perceive gravitational fluctuations, not just light? To them, Earth wouldn't appear smooth or round. It would pulse and bend, its mass flickering as matter moved through the mantle and oceans. What if their sense of shape included time? Then Earth wouldn't be static at all. It would be a spiral of history, folding over itself in waves of cause and consequence. This may sound abstract, but it echoes what theoretical physics is discovering. Space-time isn't rigid. It bends, warps, expands. Gravity, as described by Einstein, is not a force pulling things down. It's the curvature of space-time caused by mass, and Earth's mass curves space. Which means, from a four-dimensional perspective, Earth isn't just round. It's a gravitational well, a distortion in the fabric of reality. So again, what is the shape of Earth? From space, it's a globe. From the surface, it feels flat. From physics, it's an oblate spheroid. From relativity, it's a ripple in space-time. From quantum theory, it's a probabilistic arrangement of fields and particles. From ancient cosmology, it's a disk under the dome of the sky. Are any of these views more real than the others? The answer may surprise you. They're all real within their frame of reference. Because the universe doesn't hand us objective truth. It hands us data. And how we interpret that data depends on context, language, tools, and perspective. This is the essence of scientific humility. No theory is the final answer. Every truth is a model, useful, predictive, but never complete. So where does that leave the flat Earth idea? Let's be honest, the flat Earth movement, as it exists today, is not grounded in evidence. It relies on cherry-picked visuals, distrust of institutions, and a desire to feel in control of a chaotic world. But beneath the noise, the question it raises, can we trust what we're told, is a valid one. That question is the foundation of all science. And ironically, the answer to that question, yes, we can trust it, but only after testing it, is exactly what proves the Earth is not flat. Because when you do the experiments, the results are undeniable. You can measure the curvature of the Earth yourself with nothing more than a telescope and a tall building. You can witness a lunar eclipse and see Earth's round shadow on the moon. You can track satellites orbiting in arcs across the sky. You can fly around the globe and arrive where you started. You can see the gradual disappearance of distant objects below the horizon. These aren't tricks. They're consistent, repeatable, observable truths. But perhaps the most powerful evidence comes not from observations, but from implications. GPS works because Earth is round. Airplane routes are calculated using spherical trigonometry. Communications satellites rely on predictable orbits that only make sense on a globe. If the Earth were flat, none of this would function. The entire infrastructure of modern life, navigation, weather forecasting, global communication, would collapse. It doesn't, because the model works. And that's what science is, not belief, but predictive power. A flat Earth model can't predict eclipses. It can't explain time zones. It can't account for the Coriolis effect, which makes hurricanes spin in opposite directions in the northern and southern hemispheres. A spherical model can, and it does, perfectly. So we return to our earlier metaphor. Earth is not an atom. It doesn't exist in superposition. It is not flat and round at once. But the reason we explored that idea is to challenge the rigidity of perception, to show that what feels obvious isn't always accurate, and that what seems absurd may contain a hidden truth. The truth is, Earth's roundness is not a matter of debate. It's an empirical fact. But how we understand that roundness, how we teach it, explore it, question it, is where curiosity lives. And curiosity is where progress begins. Because the moment we stop asking questions, we stop discovering. And sometimes asking the wrong question, is the Earth flat, leads us to a much better one. How do we know what we know? That's the real journey, from myths to measurements, from perception to precision, from stories around the fire to instruments that read the stars. Humanity has always walked this path, from flat maps to spinning globes, from drawings in sand to images from space. But the Earth hasn't changed. We have. And maybe that's the deepest truth of all, that the Earth, whatever its shape, reflects the shape of our thinking. When our minds were limited, the Earth was flat. When our tools expanded, the Earth became round. What's next? That's up to us. Now let's talk scale. When we say the Earth is round, what does that even mean in the vastness of the universe? From the Moon, Earth is a small glowing sphere. From Neptune, a pale dot. From Alpha Centauri, it vanishes into nothing. Our entire planet, with its oceans, cities and stories, shrinks to a whisper of light. And that's not poetic exaggeration. It's physical truth. Viewed from far enough away, the Earth loses all structure. Its mountains flatten, its colors blend, its weather disappears. The roundness becomes irrelevant. Shape dissolves into scale. And this raises a question few ever ask. Is shape an absolute quality or a matter of perspective? Because to a bacterium, the skin of an orange is endless terrain. To a flea, a carpet is a forest. And to us, Earth is massive, but also just one more sphere among billions. If our minds were larger, if we could perceive like cosmic beings, would Earth still feel round? Or would it become something else entirely? A vibration, a shimmer, a fluctuation in a multidimensional field? It's not a question of fantasy. It's a challenge to the way we conceptualize truth. In physics, there are no objects. There are only interactions. What we call Earth is not a static entity. It's a complex system of energies, layers, forces and cycles. It's not just matter, it's a process. It's not a noun, it's a verb. It spins, breathes, trembles, absorbs, emits. And all of that behavior depends on the frame of reference. To an astronomer, it's a point in orbit. To a geologist, it's crust, mantle and core. To a poet, it's a mother. To a physicist, it's a mass energy distribution in curved space-time. So what is it really? Maybe that's the wrong question. Maybe the better question is, what do we need it to be? When you navigate by foot, Earth feels flat. When you launch a satellite, it must be round. When you dream, it can be whatever shape you want. Science doesn't give us one answer. It gives us the right answer for the task. And that flexibility is not a flaw. It's a feature. Because the deeper you go into any question, especially one as seemingly simple as what shape is the Earth, the more you realize how entangled truth is with context. And that's not just science. It's philosophy. It's the recognition that knowledge is layered. Some layers are intuitive. Others require instruments. And some require letting go of what we thought we knew. So yes, the Earth is round. It's been proven 1,000 ways. But it's also more than round. It's alive. It's dynamic. It's a mirror of our minds. And in that mirror, we see something humbling. That every model we've ever made, from the flat Earth to the globe, from Newton to Einstein, was never the final word. Just the best we could do at the time. Tomorrow we may see even more. Maybe we'll discover the Earth is part of a quantum lattice. Maybe we'll learn space-time folds in ways we've never imagined. Maybe the Earth's shape is not fixed, but part of an emergent geometry, dependent on observation and entanglement. It sounds impossible now. So did curved space in 1905. So did quantum tunneling. So did non-Euclidean geometry. And yet, here we are, standing on a planet that curves space, emits radiation, spins at 1,600 kilometers per hour, orbits a star, and exists as a complex electromagnetic engine we barely understand. That's the real magic. Not in fantasy, but in reality itself. Because the more we learn, the stranger the world becomes. And the more we question it, the closer we get to truth. So if anyone asks, is the Earth flat or round? You can say, it's round. But that's only the beginning of the answer. We often treat the question, is the Earth flat or round, as if it was still open for debate. But in truth, it's one of the oldest scientific questions humanity has answered. Not through belief, but through observation, logic, and experimentation. Let's begin in ancient Greece. Around 500 BCE, philosophers like Pythagoras began suspecting the Earth was round. But it wasn't until the 3rd century BCE that Eratosthenes offered one of the most elegant and conclusive demonstrations. In 2 cities, Siena and Alexandria, he measured the angle of the sun's rays at noon during the summer solstice. In Syene, the sun was directly overhead. In Alexandria, it cast a shadow. By measuring the length of that shadow and knowing the distance between the 2 cities, he calculated the circumference of the Earth with remarkable accuracy, over 2,000 years ago. Think about that. With nothing but sticks, shadows, and geometry, a human being figured out the size of a planet he couldn't even see from space. That's not guesswork. That's science at its most beautiful. Simple tools, sharp minds, and deep curiosity. Now fast forward to the age of exploration. If Earth were flat, long-distance travel would eventually reveal some edge, some boundary. But instead, ships sailed around the world and returned to where they began. Magellan's circumnavigation in the 16th century wasn't just a feat of endurance, it was a proof of geometry. The path only makes sense on a spherical surface. Later, Isaac Newton deepened our understanding by explaining why Earth isn't a perfect sphere, but an oblate spheroid, slightly flattened at the poles and bulging at the equator. This isn't abstract theory. It has consequences you can measure. For example, gravity is slightly stronger at the poles than at the equator because you're closer to Earth's center of mass. And this difference has been confirmed by sensitive instruments. The shape of Earth affects everything from ocean currents to climate patterns to satellite orbits. Then came the space age. Satellites orbiting the Earth produce images, not just one, but millions, all showing the same curved horizon, the same global outline. Weather satellites track clouds around a spherical planet. GPS systems rely on calculations that only work if Earth is round. The delay in signals, the satellite positions, the predicted routes, all based on a globe. If Earth were flat, none of this would function. Planes wouldn't fly the way they do. Satellites wouldn't behave predictably. GPS would be useless. But they do work. Perfectly. Repeatedly. Universally. Flat Earth arguments often rely on personal observation. The ground looks flat. I don't see curvature. The horizon seems level. But those are limitations of perspective, not evidence. Let's address that. Imagine standing in a vast field. The earth beneath you curves at a rate of about 8 inches per mile. That's imperceptible to the naked eye. But with the right instruments, a laser level, a theodolite, or simply a telescope, you can detect the drop. You can watch distant ships disappear hull first over the horizon. You can track the arc of the moon during an eclipse and see the circular shadow of the Earth on its surface. That shadow, by the way, is always round, no matter where the eclipse occurs. The only shape that casts a round shadow from every angle is a sphere. That's physics, not opinion. Now let's go deeper. Some argue the Earth could still behave like a quantum particle, that maybe, just maybe, it exists in superposition, being flat and round until measured by consciousness. It's a poetic metaphor, but scientifically impossible. Here's why. Quantum superposition, the idea that a particle can exist in multiple states at once, applies only to systems that are isolated, tiny, and not yet decohered. Once a system interacts with its environment, it collapses into one observable reality. That collapse is due to decoherence, a process where quantum possibilities are lost as particles interact with air, heat, light, and other particles. Earth, being made of trillions of atoms, constantly interacting with energy and matter, has long since decohered. It is not in any kind of quantum ambiguity. The Earth is massive, gravitationally active, and highly measured. It emits electromagnetic radiation. It's being observed and analyzed every second by satellites, sensors, scientists, and even by our own feet walking on its surface. In other words, Earth's reality is collapsed. Its shape is definite. It's not waiting to be defined by consciousness. It already is defined by the laws of classical physics. Trying to apply quantum mechanics to Earth's macroscopic shape is like trying to measure the weight of a truck with a microscope. The tools don't scale, the theories don't translate. But that doesn't mean we stop asking questions. In fact, asking the wrong questions often leads us to the right ones. Let's take an example. Many flat Earth proponents ask, if the Earth is round, why don't we feel like we're spinning? The answer is simple but powerful. Inertia. You don't feel motion unless it's changing. If you're on a plane flying smoothly, you don't feel its 900 km/h speed. But you feel turbulence because it introduces acceleration. Earth's rotation is constant and smooth. That's why you don't notice it. But we can measure it. The Foucault pendulum, invented in the 19th century, demonstrates Earth's rotation visually. A giant pendulum swings back and forth, but over time its plane of motion slowly rotates, a result of Earth's spin beneath it. You can see this with your own eyes in science museums across the world. Let's look at another, the Coriolis effect. It causes cyclones to spin counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. This reversal is only possible on a rotating sphere. The physics are consistent and predictable. On a flat Earth, this pattern would be inexplicable. And still, the most persuasive evidence isn't from exotic experiments or advanced physics. It's from the simple accumulation of everyday clues. The way plane routes are calculated, the way satellites move across the sky, the way stars appear and disappear in different hemispheres, the way the sun rises earlier in the east and sets in the west. All of this works because the Earth is round, and none of it would make sense on a flat model. Flat Earth theory thrives not because the data supports it, but because conspiracy appeals to emotion. It promises secret knowledge, control over truth, and a rebellion against perceived authority. But science isn't about authority. It's about evidence. It's about openness. It's about putting ideas to the test and rejecting them if they fail. And flat Earth models fail repeatedly. They cannot explain eclipses, tides, GPS, seasons, or even time zones. without inventing elaborate, untestable alternatives that collapse under scrutiny. Round Earth models, on the other hand, predict and explain everything with elegance and precision. So the next time someone asks if the Earth might still be flat, or might behave like an atom, remember this: the truth isn't shaped by imagination alone. It's shaped by what survives testing, by what works, by what aligns with everything we can see, measure, and confirm. And Earth, our pale blue dot, has shown us its shape again and again, from every direction, under every lens, across every century. Let's now address another idea that often confuses people. If the Earth is spinning and moving through space, why don't we feel it? The answer again lies in physics and in our sensory limitations. Earth rotates at about 1,670 kilometers per hour at the equator. It also orbits the Sun at roughly 107,000 kilometers per hour. Yet you feel none of that motion. Why? Because motion is only noticeable when it changes. On a smoothly moving train, you don't feel speed until it stops or turns. The same principle applies to Earth. It moves at a constant rate, and you're moving with it. This isn't a trick. It's Newton's first law. An object in motion stays in motion unless acted upon by an external force. You're part of the Earth's system, and so is everything around you. The atmosphere, the oceans, the buildings, all are rotating together, seamlessly. Now let's consider a more visual proof: airplane travel. On a flat Earth, flight paths would look radically different. But in reality, the routes planes take, especially long-haul international flights, make perfect sense only on a globe. Look at a flight from Santiago to Sydney. On a flat map, it looks absurd, flying far north before heading down to Australia. But on a globe, it's the shortest distance, known as a Great Circle route. These are used by airlines not because they're aesthetic, but because they're efficient. And they work because Earth is round. The same goes for time zones. The Sun appears to rise in the east and set in the west because Earth rotates from west to east. This rotation creates zones where the Sun is overhead at different times. On a flat Earth with a spotlight sun, a model often proposed, the pattern of daylight would behave very differently. For example, we wouldn't get consistent Terminator lines at sunrise and sunset. But we do, every day, everywhere. Then there are the seasons. On a round, tilted Earth, we experience seasons because of how sunlight strikes different hemispheres throughout the year. In June, the northern hemisphere tilts toward the sun. In December, the southern hemisphere does. This results in longer days, warmer weather, and changing solar angles. A flat Earth has no coherent model to explain this. Attempts to show the sun spiraling in circles above the surface fail to match real-world data. The lengths of days, the shift in constellations, the temperature differences, none of it aligns with the flat model. But it aligns perfectly with the spherical model. Let's now address perhaps the most compelling proof available: satellites. Every time you use GPS, you're relying on satellites that orbit a spherical Earth. These satellites don't hover above a flat surface. They orbit in elliptical paths, governed by Kepler's laws of planetary motion. They need gravity, and gravity, as we know, pulls objects toward a center of mass. That only works with a three-dimensional sphere. The GPS system relies on triangulation from at least 3 satellites, whose relative positions and delays in signal allow your device to pinpoint your location. If the Earth were flat, this entire system would collapse. The calculations wouldn't match reality. Planes would get lost, navigation would fail. But it doesn't, because the model again works. Still not convinced? Let's look at astronomy. Every celestial observation confirms a spherical Earth. When you watch the night sky, constellations change as you move north or south. Polaris, the North Star, is visible only from the northern hemisphere. As you go farther south, it dips below the horizon, something impossible on a flat plane. In the southern hemisphere, you can't see Polaris, but you can see the Southern Cross, another constellation that never appears in the north. And the stars rotate in the opposite direction in the southern sky compared to the northern one. a perfect match for a globe spinning in space. And let's not forget eclipses. During a lunar eclipse, the Earth casts a shadow on the moon. That shadow is always circular. No matter where or when the eclipse happens, a sphere is the only shape that can produce a consistent round shadow from any angle of light. And when astronauts go to space, what do they see? A globe. Videos, photos, live feeds from the International Space Station all show the same thing. Earth, round and spinning, with weather systems, oceans and land masses rotating below. Some say these images are faked. But then how do you explain private satellites, independent space agencies and amateur footage from weather balloons? Thousands of people around the world have launched cameras high enough to see Earth's curvature. You can do it yourself. It's not hidden knowledge. It's available to anyone willing to test it. Let's return now to the idea that Earth could behave like a quantum particle. Again, it's poetic but flawed. Quantum behavior, like superposition, entanglement and wave-particle duality, happens at extremely small scales. Atoms, electrons, photons, these particles operate in a realm where measurement defines reality. But the moment a system becomes too large, too entangled with its surroundings, decoherence sets in. That's why quantum behavior doesn't scale. You can't observe a basketball existing in two places at once. You can't make your car disappear by not looking at it. The Earth, being a macroscopic object interacting with trillions of particles per second, is entirely classical in its behavior. In fact, the larger the system, the less quantum it becomes. That's not speculation. That's quantum field theory, one of the most tested scientific frameworks in history. So no, Earth doesn't flicker between flat and round states. It doesn't depend on our perception to define its shape. It's not in superposition. It's not behaving like Schrödinger's cat. It's a planet, and it's round, because that's the only configuration that matches every measurement, from Eratosthenes to GPS satellites. Now let's talk about the psychology behind the flat Earth idea. It's tempting to believe that the world is lying to you, that governments, scientists and institutions are hiding some grand truth. It's seductive to feel like you have access to secret knowledge, that you see something others are too blind or brainwashed to perceive. But ask yourself, why would anyone lie about this? What could possibly be gained by hiding Earth's shape? The logistics of maintaining a global conspiracy involving pilots, physicists, astronauts, teachers, satellite engineers, and weather services across borders, languages, and generations is absurd. It doesn't hold up under scrutiny. Science doesn't need secrecy to be powerful. It needs only transparency and repetition. If you can repeat an experiment and get the same result, that's how you know it's real. And the roundness of Earth has been proven over and over by millions of people for thousands of years. The flat Earth movement, for all its noise, thrives on misinterpretation, misunderstanding how perspective works, ignoring how instruments operate, distrusting photographs, experts and evidence, not because of logic, but because of emotion. But science doesn't demand belief, it demands testing. And when you test these ideas, curvature, time zones, eclipses, satellite signals, the round Earth is the only explanation that works. And that is where the real beauty lies, not in blind trust, but in the power of proof. So let's bring everything together. The Earth is not flat, not because someone said so, not because we want it to be, but because the evidence leaves no room for doubt. From ancient geometry to satellite telemetry, from star patterns to airline routes, from time zones to lunar eclipses, every observation, every experiment, every technology that defines our modern life relies on a round Earth. And no, it doesn't behave like a quantum particle. It doesn't flicker between realities. It doesn't wait for our observation to define its form. That idea, while imaginative, is a misunderstanding of scale, physics, and science itself. But here's what it teaches us. Asking absurd questions can sometimes open extraordinary doors. It pushes us to sharpen our thinking, refine our logic, and rediscover why we know what we know. And that's the true value of curiosity, not in proving the Earth flat or round, but in testing the boundaries of thought. Because every time we do that, we get closer to something more powerful than belief. Understanding. And the more we understand this strange spinning planet beneath our feet, the more incredible it becomes.